renewable energy via windmills in Cape Town.
As countries move towards a greener future through the Net Zero by 2050 commitment, some countries need innovative methods to implement green energy into their economies. South Africa, for example, currently relies on coal for 95% of their electricity generation, with Cape Town alone releasing 27 megatons of carbon dioxide yearly. Currently, South Africa is focusing on green infrastructure and building technologies, as well as reducing carbon reliance in future technologies to help achieve their Net Zero by 2050 commitment. Because of Cape Town's massive carbon footprint, we have decided it is an ideal place to implement wind turbines within the city to harness energy from wind tunnels that occur in this downtown area of the city. Due to the city's location on the eastern edge of an anticyclonic wind system in the atmosphere, wind speeds recorded in the city reach up to 10 miles per second or 36 kilometers an hour. Within this presentation, we plan to show how Cape Town can be a prototype to implementing renewable energy in cities beyond just solar power.
The solution that we developed to reduce Cape Town's dependence on fossil fuels is to implement a windmill. Knowing it is one of the windiest cities in the world, we chose to utilize this untapped source of energy. In our design, we focus on the central business district because it consistently experiences high winds. The wind coming up from the ocean is extremely strong and is even further intensified by nearby mountains, creating a funneling effect. Additionally, the architecture of the city amplifies these winds even more. Our goal was to find a location that experiences these intense winds and is still in the heart of the city. After researching many locations, we decided the Civic Center offered the most potential. It is in the business district, is one of the tallest buildings, and faces the ocean winds head-on. Also, since it sits above the surrounding buildings, the airflow is mainly unobstructed. We also chose this location because it will allow for an easy grid connection. Since most of the energy demand is concentrated in the city, generating energy where it can be directly used will reduce transmission losses, which usually occur when turbines are located far away. With these in mind, we produce a design that will be most effective in an urban environment and maximize energy production. Using the structure of the Civic Center, we placed 12 turbines on the rooftop at a height of 25 meters and spaced 9 meters apart. The height is ideal for power generation, and the distance apart prevents airflow disturbances from adjacent turbines.
Placing the turbine 25 meters above the rooftop avoids the system to encounter recirculating wind on the near surface of the roof. The H-Darius turbine was selected for our design because this model has shown to be more performant with wind coming from below, like in our case. This vertical axis turbine harnesses most of its energy from the lift force. It has 3 twisted blades, it can handle turbulent wind, and is relatively quiet for the urban environment. The carbon fiber twisted blade allows the turbine to reach the startup speed of 3.5 meters a second at lower wind speed, and the carbon fiber also increases structural integrity of the model compared to other materials. The shape of the blade also reduces the torque loading on the structure, reducing the stress and fatigue over time. With the accessible local wind data and some assumption, the design has the potential to produce just over 100 megawatts an hour. With today's technologies, the efficiency of this type of turbine is about 23%. This is far from the theoretical maximum of 59% known as the Betz limit. To make that system economically viable with today's electricity price in Cape Town, increasing the power coefficient of the design would be essential. Because right now, in the 20-year lifespan of the design, the cost is $60,000 more than the expected revenue. These numbers are based on the QR6 vertical axis wind turbine produced by the English company Quiet Revolution.
Overall, there are positives and negatives to the implementation of the turbines within Cape Town. The harnessing of wind energy within the city can reduce the reliance on coal within the country, which currently poses a health risk to civilians living within areas close to the coal-fired power plants. A study done by the South African Medical Research Center found those living in close proximity to coal-fired power plants are at a higher risk of dying earlier, as well as may cause genetic abnormalities in babies within the region. The reduction of particulates within the air can have a highly positive effect on the country as a whole. As well as that, the decommissioning of coal-fired power plants can reduce human intervention and impacts in wildlife regions, allowing for biodiversity and animal species to return to the areas that are no longer inhabited by wildlife. The reintroduction of wildlife to these regions can help improve the local and wider area biodiversity, which can help improve the environmental, social, and cultural well-being of South Africa. However, the construction of the wind turbines may be unsafe as they're built on top of a main building in the downtown area of the city. If the building structure cannot handle the weight of the steel turbines built on top of the building, it may collapse, which can cause potential injuries and casualties if proper studies are not done to ensure the structural integrity of the building. Along with that, in the case of the wind turbines falling or collapsing, there's a set amount of space required between the turbine and any surrounding building. For our turbines, there should technically be 32.5 meters of space from any surrounding building, which they are unfortunately not since they are on top of the Civic Center and if collapsed could injure pedestrians below the building. More research will have to be done to ensure there is no collapse of the wind turbines to ensure the surrounding people are safe.